Good day, sir. Good day, everyone, and welcome to Deck Watch 322. And we are the Group E, together with my team, Decadet ABELLANA Andre, Decadet AGASA Jezreel Dave, Decadet Gasalatan Cecilieto Jr., and lastly, Decadet LAZO Joseph. And we, the Group E, will discuss to you the difference between speed over ground and speed through the water. Speed over ground is the speed of the ship in respect to the land or any fixed objects, regardless if they are in the water. An example of speed over ground are the buoys, while speed through the water is the speed of the ship with respect to the water or anything that is floating on the water. An example of speed through the water is another vessel or a boat. So a ship with her engine stopped in the water with 5 knots current will have 0 speed through the water, but it will have 5 knots speed over ground. To further understand the topic, let us welcome Decadet ABELLANA to explain the relationship between the speed over ground and the speed through the water.
Speed over ground is used for navigation, while speed through water is used for radar collision avoidance. This is in order to provide a more accurate indication of the target's aspects. We'll explain this with 3 scenarios. For all scenarios, we will have our vessel with a speed of 10 knots, and next to that is a boat with her engine off, and next to her will be land. Scenario 1. In 1 hour, our vessel would have reached 10 nautical miles because of its speed, which is 10 knots. Having no wind and no current, naturally, our distance from the boat and the land is 10 nautical miles. So our speed through water and speed over ground is the same.
At this time, there is a current going against our vessels. At 3 knots with the current, our vessel would cover only 7 nautical miles. Because of the current, with the distance from the land is only 7 nautical miles and our speed over ground is 7 knots. Due to the current and our engine of the boat will move 3 nautical miles, and when measured the distance between the boat and our vessels will be 10 nautical miles, so our speed through water is 10 nautical miles.
Good day, this is Cadet LAZO and I'm here to talk about example number 3 or scenario number 3. For the third scenario, we would have a current pushing us forward at a speed of 3 nautical miles. So in this case, in an hour, instead of traveling the initial 10 nautical miles, our vessel would instead travel at a speed of 13 nautical miles. And then the boat with no engines on will drift towards us at a speed the same that of the current, which is 3 nautical miles. In this case, when measuring from the ground, using the ground as the reference point, our vessel will travel at a speed of 13 nautical miles, meaning that our speed over ground is indeed 13 nautical miles. But if we use the drifting boat, as the reference point for our speed, we would have a speed of still 10 nautical miles, which means that our speed over water is 10 nautical miles.